So, the thing about the next goal that I'm trying to achieve is I don't know how to do some of it, a fair amount of it, because I don't use quaternions. And currently, I have to implement some changes that are going to involve quaternions. So wish me luck. I guess on the bright side, I did manage to get some rotation code working. Some rotation via shaders. Since as it turns out, you don't need that much code in order to just have a colored like triangle like I used to have here. Just a colored triangle, and to rotate that isn't terribly hard. And I managed to do it properly in a way which is consistent with standard GLSL or OpenGL practice by using a model matrix, a view matrix, and a projection matrix. And this means that by only editing this model matrix, which is what I'm doing for this mesh, updating this model matrix, I can transform the object. And that's why I've been using that to have some fun with rotating these. Let me do this like that's this fast. But I can rotate these around, this around. And I can do it around all the axes. Now, this is nice and all, but it's going to be kind of difficult to debug 3D code further without a good way to... Oh, is this not what the... Anyway, without a good way to move the camera. And currently this isn't sensitive to camera movements. Now, I don't think updating the camera should be terribly hard, but I don't think the infrastructure for it is written either. And what I want to do is be able to rotate and pan the camera. Luckily, I think panning the camera actually isn't too hard. If I just did, let me see how these are updated, actually. If I go to the OpenGL renderer, and I go to where things are rendered, it's just calling mesh.render and then update. And then update frame. This is being called in a loop. Okay, so it'll automatically refresh perspective uniforms. Although the perspective uniforms that I'm using to render these shaders aren't the same ones that are passed in here. Basically, these uniforms are used for the shaders that Grant wrote. And Grant's camera is really confusing. And it doesn't make that much sense conceptually, but it makes sense mathematically. So how can I need to come up with a way to refresh the projection matrix. Now the view matrix on each frame. Since the view matrix is going to be what it basically represents the camera's location. So let me look into this function, OpenGL.viewMatrix. So let me look into this function, OpenGL.viewMatrix. So I guess you have to give it the camera position. Okay, that's not actually used. So it has a translation you can give it, and then XYZ rotation, and then scale. Okay, that's fine. And then it's gonna, I guess, compute translation times rotation times scale. And then that's how it's gonna give you the view matrix. Which I guess is fine. What I'd really like this to just read it from the camera though. I wonder if I have access to the camera from here. I'll just try to print like renderer.camera. I do have access to that. I'm gonna see if when I render this, I can not pass these every frame. Then I'm gonna try to have something like be able to write a line like self.camera dot add updater, and then I'm gonna like update its transformation matrix. Here, this is what I'd like to do. So let's go to the renderer. That's here. I'm just gonna call update frame on each frame. I want this to be called even when there's no change, no animation being played. Will that be a problem? That might actually be a problem. Let me look at the scene code. First of all, why don't we interact? Oh, it's just regular. Oh, it's still called embedded 2 here. Let's see if I can do that instead of wait. And that's way faster, but it works. Take out the 2. It's just fun to play with. Anyway. So that does work, but if I go to play internal, for example, when I call update to time, this is going to update mobjects and then update meshes. But if I'm just in embed 2, does it do the same thing? Or what does it do in the render loop? It does update mobjects and update meshes. Okay, so the camera is neither a mobject. No, I think a camera actually is a mobject the way Grant wrote it. Let me see. I look in the OpenGL renderer. The OpenGL camera, it does inherit from OpenGL mobject. Maybe at the end. Maybe at the end of update mobjects, I should just look for updaters on the camera. Although I don't know if it really makes sense for this to inherit from mobject, because you can't. I think the way Grant wrote this, the camera has points. Yeah, it does. Origin, left, right, up, down. And so you can shift its points and things like that. But that doesn't make a ton of sense. For now, at the end of update mobjects or whatever, I'm just gonna look for updaters on the camera. So let's say or say camera.update. I think that should be sufficient. Or self.camera. Great. And that since that camera inherits from OpenGL object, then this should inherit from, and that since that camera inherits from OpenGL object, then this should inherit from def update. Yeah, so it has update. So in that case, yeah, close that. Uh-oh. Did I crash it? I don't have the version of it that I fixed yesterday where I allowed you to quit from the window. Which that reminds me. There are like 5 people in here. There's got to be some community devs. You guys, community devs, I'm talking to you, need to review my PRs. Please. But anyway, I'm gonna try adding an updater here. And this will take camera at a time. Let me just try to print. Just to try to print something. Self.camera add updater. It seems to have a problem with this add updater call. Maybe update transformation matrix. Oh yeah, that makes sense. Okay, so I am able to execute updaters added to the camera, which is great. What I think I need now is within the OpenGL renderer, each time I render, I won't want to reset the uniforms when I render. So here, when I'm rendering a mesh, it'll go to here. And this is going to reset the view matrix on each frame, and it's going to recreate that. And I don't want it to do this. The way I want it to get the view matrix is by pulling it from the camera. So maybe what I should do... Where's the... Too many windows open. Close that. I think I can close that. The OpenGL render. Maybe I should pass the camera here? Does this have a reference to the camera? Refresh perspective takes the scene.camera. So if I just... Is this what I want to do? I actually think that's not what I want to do. I think what I want to do is like get the view matrix. And this would be like OpenGL dot, or this could be scene.camera dot view matrix or something. I think it has to be get view matrix. And then I'll do like mesh.shader dot set uniform. That. And then I'll render it that way. And I think that's what I'll want to do. So what it does right now, that's going to have to change. So here, it's recreating a view matrix each time. This is going to have to go, which should crash it. Well, it didn't crash it, but it didn't render, which is about the same thing. What I'm going to want to do here, I'm just going to pass in an identity matrix. So I'm just going to say the view matrix. Actually, I hope this will be... I hope it won't crash or something. The view matrix Yeah, this way that I'm calling it, I just give no translation, no rotation, no scale. This should just be an identity matrix anyway. Although it will have some translation. So it won't be exactly an identity matrix. So it won't be exactly an identity matrix. But it will just be a translation matrix. So if I give this an identity matrix, and I just do OpenGL.matrix to shader input, and I give it the identity, I expect that this will not display. It's displaying something, like a few parts of it, but it's not displaying all of it, which I do expect. Because in order to show all of it, I'll have to translate that camera by like 11 units, I think it is. So I'll make something called default view matrix. And for this, I'm going to have just a translation matrix. And that's going to be 0, 0, 11. Robot project, what's going on? Do you have experience with quaternions by any chance? Okay, so this is translated to 11 in the Z direction, which is good. I don't, but I want to learn more about them. Okay, that's fair. Most people you pretty much only get into them if you learn robotics or like 3D programming, because they are pretty confusing. All right. So the view matrix isn't just the camera's transformation matrix. It's the camera's transformation matrix inverted. So I'm going to do lineage.in of this matrix, or performance focused 3D compute, yeah. And I don't know if I imported lineage, but I guess I did, because it didn't crash. Or I imported numpy, and I guess it came with it. I'll convert this to a shader input. And if I pass this, I think I should be able to see all the square. Perfect. Now a lot of them from IMMUs. I feel like maybe I should know what IMMUs are. However, I don't. Immunomedics. Wait, did you tell me? Okay, I guess I just don't know what they are. Motion sensors. Gotcha, okay. Okay, so this is actually a pretty good start. I have been able to encode a translation into the view matrix. So I think decreasing this number should make the square larger. And that looked about the same. Oh wait. Maybe it won't make the square larger because how am I projecting this? I'm doing an orthographic projection, which might not have perspective. IMU. Gotcha. Let me see if this is the one that doesn't have perspective. I think it is. Acceleration soar. Okay, gotcha. Reports a body's specific force, angular rate, and sometimes the orientation of the body. Similar to a gyroscope, I guess. Using acceleration accelerometers, gyroscopes, and sometimes magnetometers. Cool. That does sound like it would involve using acceleration accelerometers, gyroscopes, and sometimes magnetometers. Cool. That does sound like it would involve using quaternions. Alright, this is a means of representing three-dimensional objects in two dimensions. It has a form of parallel projection. All the project lines are orthogonal to the projection plane. Appearing in fine transformation, blah, 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 blah. So this one does not have perspective. So it would make sense that moving the camera closer doesn't make it larger. Inertial measurement on a lot of small cheap chits have quats calculation built in. That's pretty cool, doing it in hardware. However, if I translate the camera to the right, now I should see the square moved left. Okay, that's perfect. That means this is doing what I expect it to be doing. Now, instead, if I go into the renderer, go to where the rendering is performed, that reminds me some of ASICs, which have hardware built in to do a specific calculation. Usually they're used for Bitcoin mining. But it's a similar concept in which the computation is so important that they just hard code it. Okay, so here's what I'm going to do with this. Get view matrix. Maybe I'll just have this thing carry around a transformation matrix. Like if maybe all I need to do is do self.model matrix. And this can be not numpy.i. It needs to be the translated version of that. Wait. Oh man. Back to the bottom. View matrix. Let me put that back here. Okay, so that's perfect. Now I want to take the matrix that I was using to render before. So the translated model matrix. And this will be the default model matrix. And the reason for that is that conceptually, in order for the camera to look at something, it can't be on top of it. It has to be moved backwards a little. That's the conceptual understanding of a camera. The way that Grant programmed the camera that's currently in the WebGL version of Manim, it can see things when it's directly on top of them. Which is why I said earlier it doesn't make a lot of sense. Okay, so when I go to... Wait, this isn't the right file. Render.py. Render. Here. Let me write get view matrix. And what this is going to have to do is basically invert the model matrix, because that's what the view matrix is. And then call to shader input. Self.model matrix. Okay. Maybe it should just be like... Okay, yeah, this is fine. So then what I'll do is, for this mesh, do the get view matrix, and that'll automatically call the shader input. I'll load this view matrix into the shader. Now when the mesh gets rendered, here, I shouldn't have to set the view matrix at all into the shader. Now when the mesh gets rendered, here, I shouldn't have to set the view matrix at all. And that didn't work. What'd I do? Not only did it not work, but something's crashed. Wait, can I type quit? Okay. Value must be a tuple, not none type. Did I not return it? Yeah. Okay. Still didn't work. Default view matrix is not defined. Shader line 40. Yeah, here I don't need to set the view matrix. Only the model matrix and the projection matrix. Okay. Great. So this is good. Because now the camera's view matrix is being set within the render loop. So I should be able to add an updater to it. Right? I actually don't know. Maybe I should know. Let me see what scene.py does when I... Actually, I can just try this. I can do camera dot model matrix equals matrix multiply OpenGL dot translation matrix of something times camera dot model matrix. If I do like x equals dt, if I'm lucky, and I don't need to prepend OpenGL here, if I'm lucky, maybe this will, nope, what'd I do? Required positional arguments y and z. Is this how I programmed it? Translation matrix. Yeah, I need all of them. Why don't these default to 0? Should be like that. Okay. Invalid number of arguments. An updater, I'm passing self and dt. Okay. So then camera.model matrix equals numpy.mapmol. Oh, that's not how you do that. Like this, I think. Nice. Okay, so what's happening now is that I'm updating the camera's model matrix within the render loop. Wait, does this work if I do a wait? I guess because wait. Yeah, wait. Wait throttles the render loop to match the quality that you put in. So if you put in low quality, which is what I'm doing, I think it's throttling the render loop so that it matches that. But if you do embed, then it doesn't do that, so it flies off. But I'm updating the model matrix within the render loop so that in the renderer, when it gets the camera, when it gets the view matrix from the camera on each frame, it's going to successfully invert its model matrix and load that into the shader dynamically, which is great. So that's nice. I'm going to make the... Okay, first of all, the camera is like making me sick when it keeps moving like that. But I'm going to try to rotate the camera all the way around. So the way to do that would be to rotate by a rotation matrix, or multiply by a rotation matrix. And I guess I just give it a number of radians, and I want to rotate it